Hello, boys and girls. This is Mr. Kizik, and this brief video, we're going to be looking at how do we solve radical equations. So, there are 4 steps here that you need to do. The first one is you want to isolate the radical on one side of the equation. In other words, you want to get that symbol, the radical symbol, make sure that's by itself on one side, whether it's the left side or right side. The next step is to raise each side of the equation by the power of the index. So remember, the index is that number with the symbol. The reason why we do that is because we eliminate the radical sign. Then we just solve the equation like we would. And then this last step here, this is something that you have to do. You have to check for extraneous solutions, which we'll see in a couple minutes here. But step 4 is not like one of those things where you get an answer, you could just, if you don't check, you're risking it being wrong, but you hope it's right. You actually need to check your answers here. So for number 1 here, how we do this is you want to subtract 5 from both sides. Subtract 5. So I have the square root of x equals 7. Well, how do I get x by itself here? Now we go to step 2. We want to raise each side to the power of the index. So the power of the index, remember, is this imaginary 2 that's here. So we raise each side by the power of 2. So what happens here is that this becomes x, and we got 7 squared, which is 49. And that's what we think is going to be our answer. But now we got to check it. So is the square root of 49 plus 5 equal to 12? Well, what's the square root of 49? 7. Is 7 plus 5 equal to 12? Yeah. So 49 is our answer. Let's look at number 2. Is the radical by itself? No, it's not. So I got to subtract 3 on both sides. So I got negative 4th root m equals negative 3. It's still not by itself here, so I have to divide each side by negative 1 to get rid of the negative sign. So now I have the 4th root of m equals 3. The radical symbol is by itself, so now we raise each side to the power of the index. Well, here the index is 4, because it's right here. So we raise each side to the 4th power. And so here we would get m equals, let's see, 81. That's right. All right, and then you want to check it. Is 3 minus the 4th root of 81 equal to 0? Well, the 4th root of 81 is 3. Is 3 minus 3 0? Yeah, so that's right. Let's look at number 3. We need to get the radical symbol by itself. So we need to subtract 10 from both sides first. So I have the square root of a plus 7 equals 1. The radical symbol is by itself, and now we raise each side to its power, which in this case is 2. So a plus 7 equals, what's 1 squared? 1. And then I subtract 7 from both sides, and I get a equals negative 6. Let's check it. Is 10 plus the square root of negative 6 plus 7 equal to 11? 10 plus square root of 1 equal 11. What's the square root of 1? 1. Is 10 plus 1 equal to 11? Yes. So that does work too. Let's look at number 4. Again, we need to get the radical by itself. So subtract each side by 10. And I have the square root of 6w minus 5 equals negative 7. Square both sides. I get 6w minus 5 equals 49. And then we would add 5 to both sides. So we would get 54. and then divide by 6 and we get 9. Well, let's check it just to see. Square root of 6 times 9 minus 5 plus 10, does that equal 3? 6 times 9 minus 5, well, 6 times 9 is 54, minus 5 is 49. Square root of 49 is 7. 7 plus 10, does that equal 3? No. So that means this right here, 9 is not the answer. And in fact, my answer is no solution. So that's why there's the importance of checking your answers here, because sometimes you'll just get an incorrect answer. Now, does that mean we did the problem incorrectly? No, it is not. If I look here at this step, we should have actually just stopped right there, or we should have realized that's incorrect. Because what we had was the square root of something equals a negative number. But think about it. Can I ever have the square root of something, again, a negative number? And the answer is no. You're always going to get a positive number. So that's why this is no solution here. All right, let's see. Is there any other ones I want to see here? No, that involves that. I don't think so. Yeah, so that'll be about it here. All right, so that's the basics of how you would solve radical equations. Again,